As Roberto said, the title of this presentation is Workflows for Hybrid Teams in Product Development. During the course of this presentation I will explain you why we call it like this. Yes, but first I want to propose a question to all of you. When hearing all these presentations and talking about optimization, about automation, you almost kind of think that in a few years people aren't needed anymore. It's just all automation, all done by computers. Well, this is a question I want to give to you for the course of this presentation, and then in the end I will give my view on this question. So what will I be explaining in the coming 15-20 minutes? I will be explaining the next step in integrating the human and the computerized workflows in product development. My name is Maarten Elissen. I graduated at the Delft University of Technology as a mechanical engineer. The main topic of my graduation was advanced engineering informatics. I currently work at Keyworks. I'm a knowledge engineer there. I work in several research projects. I also help in writing proposals for new research projects. And I develop software in several customer cases. First I want to pay gratitude to all the other partners in iProd for their help in contributing to the research and to make this all happen. And of course the European Union for funding the iProd project. I will start with giving an introduction in the problem we address and the things we found out in the product development process. I will then explain to you the workflow for hybrid teams we introduce and how this works for the car door design, structural design. And I will end up with a summary and conclusions. What we see in the product development process is that the product development process is getting highly complicated. There's a huge amount of data to generate, analyze and manage, but the resources are getting limited. People are retiring, people are not going into engineering or going into alpha studies. So we need to find a way to keep the knowledge inside the companies. Furthermore, there's also a need for lead time, cost and quality, lead time reduction, cost reduction and quality improvement. This is also due to the globalization. It's getting much more competitive in the world. So you need deeper specialization, more flexible and open processes, and collaboration between multiple companies is required. And also, of course, the economic crisis is a result of this. It's resulting in this. So I want to be more productive and more flexible with similar or fewer resources. If you take a look at a generic product development process for engineering, this is highly complex and spanning many stakeholders. It's getting very knowledge intensive. It's often human and business centric, and it's multidisciplinary. This is the process we use in iProd, but it's the same as, for example, the well-known V diagram. If you take a look at these product development processes inside a company, often the ICT environment is composed of competence-based desktop software. And a large level of human interaction is required. Furthermore, this information, the product development process is divided into silos. As you can see in this small picture, we have, for example, the design engineering department, the manufacturing engineering department, and the production preparation department. They all have their own data silo with all the information they need, with all the tools they need. It's working quite well for them in that silo. But there's actually, every time there's a gate to the next department, which is going to do their own process again and store their own data and their own models. There's no lean engineering process. Efforts are wasted in identifying, searching for information. Information is produced multiple times in each silo. The same information is produced, or at least some of the same information. There are quality issues, and you're waiting a long time for your information, because the design engineering information will only be passed over if they're totally finished. If you then take one step back and you take a look at the entire environment, And also the product development process is becoming a network of companies. So there are multiple companies working on the same end product. They're all doing their own thing, and they all should be able to work together and work on the same end goal. So what do we propose as a solution for this kind of problem? Let me first introduce you how we see a workflow. We see a workflow as a sequence of tasks connected to a separated flow of information, and it's resulting in a final outcome. And we also notice the flow paradigm, which says that tasks follow each other without delay, and the waste is being eliminated. And often the subject of a workflow is the product information. A workflow management system in this sense is a computerized system which manages and defines a series of tasks within an organization to effectively produce a final outcome or result. So we propose to build a workflow for hybrid teams. What do we mean with that? We mean a workflow which is integrating the human-oriented PDP activities with the simulation workflows which are currently in these data silos. And these simulation workflows are acting as agents, part of the same team. So that's then a hybrid team. Furthermore, the solution will have a flexible and integrated ICT environment. It will try to effectively manage knowledge. It will support interfunctional and cross-organizational collaboration. And it will improve the PDP automation to spend less time on repetitive work. If you take a look at the solution from a high level, there are 4 layers in the development process we identified. The first one is the human workflow management system layer. It's an organizational layer, it's business-centered, often modeled with, for example, business process modeling language, and the main actors are design engineers, program managers. And there's a second layer, this is the integration layer. This is where the simulation workflows are integrated. Simulation tools are integrated in simulation workflows. In the first presentation of the previous session, Roberto talked about mostly about this layer and down. Then the third layer is the domain-specific applications layer. Here, domain-specific applications are built using engineering knowledge to automate single steps in the workflow. And the last layer is the knowledge base, which is a central storage of information for the entire product development, which can be used by all the other layers. And then all these layers are connected to a software integration framework, which is aware of all these layers and of all the models which are used in there and all the knowledge which is used, and connecting them together to build one product. So from an engineering point of view, how will this work? Well, an engineer will start by requesting the PDP workflow from the system. Then via the human workflow management system, the information will be retrieved from the knowledge base and sent back to the engineer. It will then see the high-level human-oriented workflow, including the simulation tasks. And the human can start executing tasks. It can start execute human tasks, execute work, and fill in the information in sheets, in spreadsheets, or in forms, etc. This is all done using the human workflow system. It will not touch the simulation workflow system, but the knowledge will be stored in the central knowledge base. Then the second part which can be done is executing simulation workflows. If a user tries to execute a simulation workflow, the request is sent to the human workflow management system. Via the human workflow management system, the request is sent to the software integration framework. Software integration framework will retrieve all the knowledge necessary for executing the simulation workflow and ask the simulation workflow management system to execute this workflow. The results of the workflow are then sent back via the software integration framework to the human workflow and shown there to the user to evaluate and to use in the next human steps. And the last function is the create, read, update and delete simulation workflows, which is directly connecting to the simulation workflow management system to edit or add new simulation workflows. So how did we implement this in the case study in iProd? We used the car door structural design use case. We started defining the entire workflow from the start of the door design until the end of the testing phase. What you see here is the yellow tasks are human tasks, the blue tasks are simulation tasks, and the red-orange tasks are physical tests. So this is an integrated workflow with both humans and simulation workflow agents. For the human workflow management system, we implemented software keychain. This is a lean engineering workflow management system. It efficiently manages and defines a workflow of engineering tasks. And the main characteristics of the system are a generated lean engineering process, integrated change management and configuration management, dynamic product modeling, and a customized view on integrating content management systems like ERP, handbooks, guidelines. This is a picture of how this looks like. It will return in a later presentation as well. The hybrid workflow integrates the human the simulation workflow management system, which is Deutsche Optimus, already presented a bit earlier by Roberto. And the central knowledge base is built onto Franz and Lego Love. We'll not go into detail about how this works because it will be explained a bit more in other presentations. And the integration is done via the software integration framework. In the end, the workflow looks like this. This is only a part of the workflow. There are multiple, but I will not go into detail about that. The hybrid workflow allows humans and tools and simulation workflows to continuously and concurrently execute work, interact across the web on the same product or final or partial product. I would like to invite you all to the presentation of Maurice tomorrow at 10 o'clock, because he will be demonstrating the entire software framework, including everything what I've told and shown right now. This is in the same room as here. So to conclude, we proposed an open and consistent framework for supporting hybrid workflows. This framework is geared towards direct industrial implementation. It allows for increasing the number of design options to be evaluated, and it supports a collaborative environment to work together on one final product. And it supports traceability of tasks and repeatability of task patterns. And in the end, it will improve quality and save time and cost. The next steps in our development will be integrating the task planning to support project management. After that, we will be generating workflows automatically from the knowledge stored in the knowledge base, and we will integrate also the optimization workflows based on the work from Paragon. And in the long term, we will be integrating the requirements management and compliance so that we can automatically check the compliance of a product design based on the requirements defined in earlier modules. So to come back to the question I proposed in the beginning of the presentation, my view is that computers will always need some kind of human interaction. So a smooth integration of both humans and computers is the most promising future, in my opinion.